Good morning, class. Today, we're now on the topic Deformation of Rocks. This is the Earth Science of Grade 11 of Kawayan City National High School, Maine Senior High School.
Maybe you could find more kind, babe.
So, how the rocks are being deformed? Rock deformation is a process of changing transformation of rocks due to stress and heat. Structural geology is the study of rock deformation. There are types of deformation of rocks. Number one is folds. The second is faults. And the third one is joints. Joint has no plate movement. Fault has plate movement that has occurred. Faults are flat-lying sedimentary and volcanic rocks that are often bent into a series of wave-like undulations. There are two most common types, the anticline and the syncline, domes and basins. Faults. Faults are fractures in the crust along which appreciable displacement has occurred on a scale from centimeter to kilometer. There are three types of faults. One is deep slip faults. The other one is strike slip faults. And the third one is the tensional and compressional forces faults, which is the thrust. This is the strike slip that is slipped for a little bit distance, and this is the normal faults, and this is the thrust. The normal faults, one is going up on the left side and the other one is going down to the right side, while the thrust is the opposite of the normal. The other one is going the right side is going up and the left side is going down. That is false. What about joints? Joints are most common rock structures which are fractures. These are fractures along which no appreciable displacement has occurred. There are two types of joints. One is columnar joints and the other one is sheeting joints. So this is how a joint looks like. There are fractures between the rocks. Structural geology is the study of rock deformation. Features of rock deformation are collectively referred to as structure or structural features. Stress and strain terms, these are used to describe the type of rock deformation. Stress is the force applied to a body or a unit area. There are two types of stress. One is uniform or confining stress, which is the force on the body that is equal in all directions. does not usually deform a rack or change the rack shape, but may result in a change in the size of the rack. The other one is differential stress. These are stress that is not equal in all directions and is caused by tectonic forces, usually causes a change in shape, but not in size. So the opposite of uniform confining stress is differential stress. There are three types of differential stress. One is tension, which is a stretching stress, wherein rocks have very little strength under tensional stress and break apart easily. The second one is compression. It is the squeezing stress. Rocks are relatively strong under this compression. The third one is the shear. Stress operates in opposite direction across the body. So this is the compressive stress, the tensional stress, and the shear stress. So when under compressive stress, folding is like this. So compressive stress, it folds the rocks and it results to faulting. Tensional stress results to stretching and thinning of the rocks and also faulting. Shear stress results in shearing and it also results to faulting. Strain. Strain is the deformation or change of shape of a rock body. Experiences when under differential stress. Strain is proportional to stress. So large stress is equal to large strains. There are three types of strain. One is elastic strain deformation, which is recoverable strain. The second one is plastic strain ductile deformation, which is a permanent strain. When stress exceeds the strength of the rock will bend or fold. The third one is brittle strain deformation. It is a permanent strain. When stress exceeds the strength of the rock will break or fracture. Elastic strain deformation is the recoverable strain. When stress is removed, object regains original shape, like a rubber band. Elastic limit is the limiting stress beyond which the rock cannot return to its original shape and will be permanently deformed. Depends on the rock involved and temperature, or the rock type and the temperature. Plastic strain ductile deformation, which is a permanent strain, happens when rock is stressed beyond the elastic limit and when stress is removed, the object remains deformed by bending, for example, like cheese. Brittle strain deformation. It is a permanent strain. When stress exceeds the strength of the rock will break or fracture. For example, chalk. Factors that influence the type of permanent strain in rocks experiencing the same amount of stress. We have number one, the temperature. The second one, confining stress. Third, the time and strain rate. The fourth one is composition, important in two ways. One, it is important in mineral composition, and the second one is the amount of water in rock. So this is how the brittle strain looks like. It results to the reverse faulting, the normal faulting, and the strike slip faulting. Looks like this. Plastic strain, it will result to foliating, folding, stretching, and shearing. This is folding, stretching, this is shearing. Plastic strain folding, This is the horizontal fold. This is the fold of axis. When strain is being applied, it will form like this. The rock will form like this. This is the flying fold. This is the horizontal axis. The anticline fold, the oldest formation exposed on the surface. This is the youngest formation, and this is composed of gas and oil. So this is an anticline fold. You can see here the oldest formation exposed on the surface. The syncline fold. We have the sandstone, the gray shale, the red shale line is composed of limestone. This is the youngest bed, and this is the oldest bed. So this is how the sink fold looks like. We have the upper surface here, and it composed of different types of rocks. Asymmetrical fold, it looks like this. The direction is upward, and it forms like a wave, like this one. Overturned folds. This is a more bend or more ways bending to the right side direction. Plunging folds. This is how plunging folds looks like. Plunging anticline. You can see some folds when there is a plunging over here. The direction is here. Plunging syncline. The direction is here. The opposite of the plunging. The other one. So rock folding is influenced by the type of rock and the compressive forces exerted on the rock. So it can be an anticline, syncline. You can see an oldest rock here, and on the upper portion is the youngest rock. So it depends upon the type of rock and the compression forces that rocks will be folded or being fractured. Thank you for watching. Please like and subscribe to my channel.